Um, First, this is a fairly involved book, so this is going to be the topic of discussion for probably the next few sessions. Hope those of you are watching will get some nice lessons out of this. We won't be directly going through each of the individual code examples in the Metaobject protocol because one, they're fairly involved, and two, I'd like you to uh, really purchase the book, read through it, and come to your own conclusions because there are exercises in here as well that I'd like us to go through and probably do our own implementations of things. Uh, Outside of that, we're still looking for talks as usual. For folks who want to give like a side talk or have topics of discussion, feel free to go ahead and post on the CL study group that's on Mattermost, as well as the Lisp Discord server, and I'm on the Lisp channel in functional programming.slack, usually just hanging out in there. Those are multiple avenues to get in touch with me, as well as the other members of the study group, so that we can get those topics in, and hopefully we can get to them as soon as we can. To get started, I wanted to at least bring kind of an agreement as to what is the Metaobject protocol, where it kind of stands in the guise of CLOS. Just because when I first started reading this, I had kind of one distinction on what they were talking about. And as I started reading the first chapter, which is what we'll be covering today, a couple of things were cleared up. Really, to get things started, and hopefully other folks that are on could correct me if they're more familiar with the material. But my understanding of the Metaobject protocol really is it's a low-level interface to how objects are defined in Lisp. Is that a fair assessment? Like Jason, Michael, Fiano, I'm sure both of you probably have looked into this off and on.
Yeah, I mean, that's pretty, yeah, I mean, the only thing is that, it's an addition to the standard. It's not actually standardized, so whether or not it exists in Lisp is up to the implementation.
Okay.
And the other thing that I like to mention is that it's specifically to CLOS objects.
Yes.
Whether or not other parts of the language are built using the CLOS machinery is also very implementation defined. And so while, if you have the Metaobject protocol, that definitely means you have access to this kind of stuff specifically for the things the standard says are in CLOS. Exactly how much that'll extend to the rest of the object system in the language is also a bit funky. Right. So like there's a degree to which on SBCL that you can apply the, MOP machinery to structs, for example, but that's not by any means, it's less portable than the MOP is. Right.
Right. But one question I had is because you just, brought up the maturity of a particular implementation and some decisions is right now, if you use any standard function against primitive types versus classes, they don't make any distinction behind the scenes, because my understanding is that the primitive types have some sort of machinery that's hooked into the I guess standard class, which is part of the Metaobject protocol. It's not like this is where kind of like my confusion comes from.
So the thing is that there are a lot of classes in the spec that are not guaranteed to be standard classes, right? They're referred to in the spec as system classes, and a system class is allowed to be implemented using CLOS, but it's also allowed to be implemented using some other implementation internal means. And so there are a lot of classes in the spec that, like number, for example. Number is a class in the spec. And so I guess the first thing to realize is that every object in Lisp has a class. All of them do. Every single thing that you can stick in a variable is an object, and they all have some class. However, not all objects are CLOS objects, and not all classes are CLOS classes. That's really sort of the big thing to get used to, right? CLOS is a subsystem of the main Lisp, the full Lisp object model, right? And
yeah,
it
actually,
only governs on a
class
sub.
is a super type of standard object, and built-in class is a superclass of class, if I recall correctly.
Class.
Let me try something. Let's try integer here, right? Or bit. Actually, let me try a bigger number, like a
Do class of.
class of. Yeah, that's
Class
a
of.
good idea. Class of. Okay, so let me go and actually embed. So what?
Yeah, the class precedence list of built-in classes. Built-in class T.
Okay.
So fixnum is a built-in class on
Fixnum is a
SBCL.
built-in class, which is subclasses of integer and goes up the stack to eventually T. At some point, we'll hit T, right? Yeah, we
Right.
did. So the top level object that hooks CLOS and the rest of the primitive objects is T,
No.
right?
No.
Okay.
T is the name of a class. There's a class named T, right? It's a
Right.
system class, right?
But
T is not governed by CLOS. The T class is not governed by CLOS.
The T class is not governed by CLOS. Okay.
Right. The standard class standard object is really the top of the CLOS hierarchy.
Okay, hold on.
What
I'm trying to do is do def class here.
If you do find class, find dash class. Oh, okay, yeah, sure. That works. Find class, name of class. Yeah, sure. Point.
Okay, so this is something that I just defined,
Sure.
and if we look at the class precedence list,
T will be in there, but it'll be higher up than. Yeah, if you look at the class precedence list. Oh, it actually doesn't have a class precedence list yet because that's a forward referenced class. You haven't ever created one. Make one.
Okay. Let me click this.
Or it's not finalized yet. Sorry, that's the terminology.
Oh, finalized. Okay, that's what that finalized inheritance function that they were mentioning in the book that they were talking about. Okay, so let me make an instance here.
Yeah, the simplest way to force finalization is to make one.
Okay.
Make an instance, yeah.
Sorry. Point x is 0.1 is 0. Okay, so what? Wait a second, did I mess something up here in my definition?
Yeah, you didn't make your init args keywords.
Ah, dang it. That's right. Thank you. That's right. All right, let's do this again. All right, so if I do this,
and then click on the class.
And now you can, click on the class.
There it is. Okay. So
and now you'll have a class precedence list. And you can actually tab to that.
There we go.
Yeah, there you are. Point, standard object, slot object, T.
Standard oh right, and standard object is a standard class, right? Like
yes. And standard object is the top of CLOS.
Standard object is the top of CLOS. Okay.
Yep. CLOS only really has control over stuff that's within the standard object space or other instances of meta classes that you create using the MOP.
So is the MOP, so to extend the MOP, and let's say that I want to create an object that's automatically logged, okay, to some log file. Dumb example, but we'll go with it, okay?
Sure.
Do I then subclass standard object, or do I subclass standard?
So if you're defining a class, you would subclass standard class.
Okay.
If you're just to do that though, right? Just to make an object that gets logged during initialization, you don't need the MOP at all. You could just make a class that has a method that does the thing.
Right. No, I'm not. And I understand that. I'm making a very contrived example just to
Sure.
understand where things are coming from. So I would
So you
do.
make an instance of standard class.
Okay. So I would do this. You would say loggable, and this will be standard class.
Yep.
And then, okay, got it.
Are you talking about the example we came up with a couple of weeks ago where any change to any slot in said class is logged such that we could, back up and retrieve the previous state of that class?
That is where I was going, but
Yeah,
that
that you do need the MOP for.
because that way you could create like a history of changes that are being made.
Yeah. Okay.
And that would allow you to go back and forth and rewind and replay if you wanted to see changes. But obviously, to make that kind of example, you have to understand the MOP, right? So
Yeah.
that's where I was coming from on that. But once I do this, I'm guessing. I'm skipping ahead, but let me get started on first kind of mentioning what to folks who haven't actually seen this before, what this is. So what we're talking about is in meta objects and defining classes is kind of a set of classes that are what the book calls class meta objects. Okay, these are essentially internal data structures that manage what a class definition has. So when you are defining a class, like let's say our point class that you see here, internally, this is actually not how it is represented in the MOP. It actually has its own set of structures that it will create when you create an instance of this. And we kind of saw this when we were inspecting our point class. If we actually look at our point class's definition, you'll see that in the MOP that's in the book, there's it's a smaller subset of this, of course, but it still has the same methods, which is you have a list of your direct slots, what your direct classes are, if you have any direct classes, your direct subclasses, that is. If you have any direct superclasses, that is what you're inheriting from. Whether what the precedence list is, that's useful for say method lookup. And one thing I noticed in the example that's in the book is he has a separate list for readers and writers. I didn't see when I was going through this the other day, readers and writers inside the structure here. But I guess, as you mentioned, Elijah, there's maybe an implementation detail as to whether or not they would have that exact MOP.
Correct.
Location. But the majority of these are available for you. And what happens is when you actually instantiate a class, what it does is it calls another function internally to look up in what they call the global database of all available object definitions that were loaded into your Lisp image, checks to see if the object definition is there. And if it's not, it defines it, and it then calls, and this is where, a good point of discussion I wanted to bring up, a couple of things that will construct different portions of the object, primarily something that they call the canonicalize procedures for creating your superclasses, creating your slots, and creating your options. Now, question one, and I don't think I remember this, so this might have been in some earlier discussions on CLOS that I have to go and refer to, but I don't remember us talking about options in def class. Are those something outside of is that like documentation? Like if you want to document your string or whatnot, or
so documentation is a standard class option, yes. Meta class is another standard class option. Default init args.
Default init args. Okay, see, these are options that are extending the basic things that are constructing, that are being used after the class is constructed, I guess, because the way EnsureClass looks like it works is it literally does nothing more than, it's a function that does nothing more than passes all those key arguments to make instance, and make instance does its magic to actually go and construct the object.
It makes the class.
Now, the class, the make instance apply in EnsureClass, if we ever want to write this from scratch using standard common Lisp than what's in the book. And I'll just bring this kind of example. Is EnsureClass is really the nuts and bolts of this thing that takes the class name and all keys. But if we want to do this here in standard common Lisp, I would think that what you'd want to do is you'd want to, first find the class. If the class is not available, then throw an error saying that it doesn't exist. Class doesn't exist.
Well, no, because the whole point of EnsureClass is to make it if it doesn't exist.
Sorry, if it exists, throw an error saying that class exists. That's what I meant. Sorry, because right now we're not dealing with redefinition. Okay. We're ignoring redefinition for a moment here. Okay. So I think that's what they did. Yeah. Name. Yeah. Class. And folks coming from other languages, I know class is a reserved keyword in those languages. It's not in Common Lisp, but for the sake of making it clear, I'll go ahead and say class name.
Okay.
That way, it's better. Okay. And if it doesn't exist, then we call apply to make instance that takes it in. And then this is where it becomes a little, I just want to make sure I'm understanding this. So if I wanted to say class instance, I do apply on make instance. I don't need the hash quote.
You need to.
Right? You do need the hash quote there.
Yeah. Okay. I wasn't sure because I remember we had this discussion on sometimes the sharp quote isn't necessarily needed, so I want to at least double check here. Now instead of
at the very least, you would need the quote because that's a function, and make instance would be evaluated.
Yeah.
So what we'd have to do is pass in all keys here, and then we then have to...
No, not standard object.
Not standard object. Standard class. Okay, that's what I wanted to see, because behind the scenes it looked like it said standard object, and that's why I wasn't sure if it would still be the same, if it'd still be standard class.
No, that doesn't really. Oh well, it depends on exactly how advanced their implementation of CLOS is, I guess. It's been a little while since I've read through the early chapters of AMOP, so I forget exactly where they are right now. I mean, every standard class is a standard object. And this is one of those weird places where there's a circular definition involved that requires some initial bootstrapping when your system, creates CLOS. But every standard class is actually a standard object. And so they could have just been sort of skipping the little detail that standard class is a subclass of standard object.
So standard class, okay, so that's where I wasn't sure about. I should have actually double checked. I wasn't sure if I saw this in their hierarchical structure of the color rectangle example, where they're both subclasses of standard object, but then they defined standard class, and that led me to believe that standard class was a much more lower level object than standard object was.
Nope,
that's not the case. It's the other way around. Standard object is the lowest.
So you can't describe either as being lower because it's actually circular.
Okay.
Standard object is an instance of standard class. Standard class is a subclass of standard object. You can't create them separately. It's part of the bootstrapping procedure of CLOS. The two objects both sort of come into existence at the same time, set up that way.
Okay, so that's the metacircular portion of the initialization.
Yep. The only way to really make CLOS internally consistent is if standard class is an instance of is a subclass of standard object, but standard object is also an instance of standard class. And really, what it is basically it doesn't actually matter initialization wise because neither of them are initialized using the MOP machinery, right? And once they are finished being initialized, the MOP is already set up. And so any future operations of them can use the regular MOP machinery, but that requires that they be set in that particular circular way.
Okay.
To make everything resolve properly later on.
Okay.
Right.
So
like.
Go ahead.
Quick question. Since we're talking about metacircularity, this is one of the things that confused me in the book because like he starts with the class definition of standard class using def class, which is not defined yet.
Oh yeah, well, I mean, presumably he's probably expecting you to be using your Lisps.
Right. You're using CLOS, but that's my question. Like, how does he bootstrap? Right, because this is supposed to be the implementation for later.
So you can't actually do that, right? If you're actually implementing Common Lisp, you can't actually do that. The short answer is that in order to actually do that bootstrapping, you do actually need access to implementation internals, like access to implementation internals that aren't even exposed by the MOP, like the ability to go in and manually manipulate the wide tag of a pointer.
All right, so because then that leads to my next question, which is so like when he defines standard class using def class, and then he's doing other stuff later, and he he defines the macro for def class, and then he makes another def class later. Am I to assume that that's the macro, a call to the macro that he made, or still a call to the regular class system?
I don't know because I haven't read that in a while.
I'm assuming it still calls to the regular class system.
Probably.
Okay.
Hard to say. So it's possible that at that point he has bootstrapped it enough that you can actually just work in it. I don't know for certain though. So like when you're doing all of this in an actual Lisp, right? The way you would actually do it is that you manually create the actual objects, standard object and standard class, using some lower level but compatible means, right? So there's PCL, portable common loops. I don't know why it's called that.
I think it's because when Carnegie Mellon created because that's where SPCL comes from, right?
Right.
They wrote it back in the 80s. They had their own, I think, implementation of loops. Prior
common
to
loops.
Standardization.
Common loops, which was an earlier object system.
Right. And I don't think
what I don't understand is why they named their object system loops.
I think didn't Symbolics name it loops?
Possibly, yes. Lisp object-oriented programming system. I just came up with that on the spot. I have no clue.
That's actually what it is. Yeah.
Really? Okay. Fair enough. Anyway, so PCL is still the foundation of CLOS in SPCL. But basically, the way that you do it, right, is that you have to you have to create the object, standard object, and standard class in a way that's compatible with the MOP. But you don't create them using the MOP. You create them using some other means. And when you create them by hand that way, you create them such that, as far as the MOP is concerned, it looks like standard object is an instance of standard class, but standard class is a subclass of standard object. And so you have to basically create those first two objects by hand using some other lower level means.
Well, that brings up a question for me too. Then, because if that's truly the case, if that is the case, right? Cosette actually, I guess it's at least the simpler example that they made. there probably is a different set of objects then that they need for the meta circularity, because standard class here doesn't subclass from standard object at all. It is just a top level object, at least in the book. So
yeah, that's entirely possible. It's possible that CLOS set isn't that circular.
Okay, all right.
Because it probably doesn't need to be, because it doesn't implement the meta object protocol to the same degree that CLOS does, to the point where you wouldn't be able to accomplish certain things if you don't have that particular circularity.
Okay, cool.
That'd be my guess.
That's a good. Thanks for that clarification, because your explanation makes sense in a. Go ahead, Michael. Michael Garano.
Oh, sorry. Yeah, my connection's kind of funky. So yeah, that's the thing that's like a little confusing about this book, is they seem to be like hopping in and out of talking about how this works in CLOS and saying they're implementing it, but then they kind of gloss over like a lot of detail. So it's kind of hard to keep track of like what's important and what isn't, because it just gets a little confusing sometimes.
I mean, what they're trying to do is show you how to implement CLOS using CLOS, right? Implement something that's CLOS-like using CLOS.
Right.
That's the idea. Basically, just to give you an intuition for how the machinery of CLOS can be implemented using the machinery of CLOS, and to give you an intuition for how you can then extend CLOS using the APIs in the MOP. But you can't sort of then, and they may not make this clear enough, that may be a flaw in the book, you can't then assume that this is actually how CLOS is set up in your Lisp, because there are extra circularities in the actual implementation.
Right. So one thing I will mention that Chapter 1 explicitly said when before they started actually explaining the different implementations that I've been trying to pay close attention to, is that, and for folks who have been kind of glossing over to the start of the implementation, you should at least read section 1.1, because there's a lot of stuff that's missing in part 1. They mentioned that is no class redefinition in close set, no method redefinition, no forward referencing classes, no method combination, only standard method combination, no equal specializers, no shared variables between classes, so you can't have class instance variables. There's a lot of stuff that's just not implemented. But in part 2, when they start going through the MOP specification as is for CLOS, they start introducing some of that. So I think we're, at least for me, I noticed that I've been kind of jumping ahead, saying, okay, well, that's interesting, but how do you do this, So I'm trying to. I guess Michael, you and I are kind of doing the same thing, where we're kind of jumping ahead in the book to see what do they actually implement for all these other cool features that are in CLOS. But
yeah, well, they told you to go to the back of the book to look at the code, right? And then the code has more features implemented than what they're talking about, which they mentioned. But then it's hard to keep track, because like they were doing those like extra slot definitions, and then they have like meta objects for the slots. But then they say, well, don't worry about that. But then like they reference them all over the place, so it's it's confusing as like what they actually do or why they might be important. So
right.
I don't know. I was surprised. I thought it could be, I guess, written slightly better, but it is what it is, and it's interesting. So try to pay attention and keep track.
So to finish off this implementation, then this actually is the implementation of EnsureFlex, which is basically you do a lookup in our global database, you check to see if it's nil, if it's available. If it is, you can't redefine it. In which case, I threw an error here, just like the book suggests, and then we are actually setting up our class definite instance here.
If you want to skip ahead a little further, so firstly, you don't actually need to do that, because setf returns the thing that got assigned.
Yeah, the book does this, so I could clean that up there. That's actually a good note. So,
I mean, it's sort of it's a style thing. Some people like to make it explicit that they're also returning that. But anyway, if you want to skip ahead even a little further, getting that to the point where it does actually
Sorry, just finishing, just cleaning this up.
handle redefinition isn't very hard. It just has to, you have to assume that a lot of other bits of the Metaobject protocol already work. But the actual definition of EnsureClass, the full one, isn't actually much more complicated than that.
Interesting.
You instead do let C be find class name. No, outside of all that, because you only want to call find class once.
Oh, okay, got it.
Basically, I'm just saying use an anaphoric if.
Oh.
I'm just, I want you to grab the class if it exists.
Got it.
So you can either do a let and then an if, or pull in some library that gives you an anaphoric if macro, or however you want to represent that. But
got it. Let's just do a let for now, just because I don't have I don't remember where my macro library is of all the stuff that we did from let over lambda sitting around.
Well, actually, Alexandria has if let.
Oh, it does. Yeah. I actually have that available, so I could do that. That's actually not a bad idea. Okay. If Alexander, did I put that? No, I didn't. Hold on. We redefined this. This guy is local nicknames. Now we're going full SBCL here.
Well, SBCL and quite a lot of other implementations these days.
Oh, really?
Okay. Yeah, the only one that doesn't now is C-Lisp. Even LispWorks and Allegro recently got it.
Nice. What? Dang it. 1 second.
Yeah, I need to load that.
Yeah. Quick load. Hold on. Not until I actually have this as a dependency. And something is complaining about. What is it?
Q.
Oh, okay.
Q. You're good. I see what the error is. It's not an actual problem.
Okay.
Yeah, and then head back over here and redefine your package. Just redefine the package.
All right.
And then go down, because basically the thing that errored is that Alexandria doesn't have an if symbol; it just has an if let symbol.
Okay. If what?
And then wrap an extra pair of parens around the find class. 2 pairs, actually.
2 pairs? 1 more?
2 pairs. Yep.
Yes. Okay, that's
Because
right.
it's a let.
That's right. Okay.
And now in the
I can label it, so I guess class def. Okay.
I mean, that actually is the class, but sure. And then hit, Shift O.
Shift O. Okay. Yeah. Oh, that's right. Okay.
And then apply.
Make instance, I guess.
Reinitialize instance.
Reinitialize instance. Got it.
1 second.
Class.
Yeah, basically give the same args to initialize instance that you're giving to make instance.
Got it. Oh, okay.
Except not the standard class. You don't need that. Because it knows what class it is already. And then just all keys.
Okay, got it. All right.
Okay. And then re-indent that, because it's, not indented properly anymore.
Yeah, I noticed.
And you got an extra close paren.
What? Oh, this happens every time I do this. Okay. All right.
Now, assuming the rest of the MOP machinery is functioning properly, that'll do it.
It's a bit more complicated the way Closer MOP does it. It has a method instead of reinitialize instance. It has a method that's called whether the class is null or an actual class, and then it does like nonsense like ensures that the that there's a lock held, so two threads can't compete. It's really complicated. It has a whole bunch of custom methods just for doing this EnsureFlex.
But that would imply that it's not even using a lot of it. It's assuming that a lot of the machinery for standard CLOS doesn't exist, and it's just re-implementing some stuff from scratch, doesn't it? Like it's just
bits of it, yeah. Well,
yeah.
Closure MOP is a portability layer, and so it has to actually pave over some cases where some implementations don't adhere to the MOP precisely.
Okay.
And so probably what it's doing there, it's just, re-implementing a particular thing because a lot of implementations do it slightly differently and it wants it to be exactly the same everywhere it goes.
Interesting. So one thing that I wanted to ask, just because this is kind of getting into some of the nitty-gritties of how once we've instantiated this class, it's actually available.
Mm-hmm.
I'm assuming that this object is allocated somewhere in the image, right, for later reinitialization. Is that what they're talking about when they're saying allocate slot storage and allocate standard instance? Like, are they grabbing essentially like a malloc somewhere?
Basically,
a block of memory. Okay, gotcha. Okay.
Yeah, allocate instance.
So allocate instance is just a memory allocation. Okay.
Well, given a class definition, sure.
Right. Well, that's what I mean. And I just wanted to make sure that when I was reading through it, it says that it says it's creating a new standard instance. I was like, okay, so internally somewhere there is a cons that's happening. I'm guessing that's allocating enough storage for this class definition.
So every call to make instance calls allocate instance and then calls initialize instance.
Okay.
And the same is true for meta objects. Meta objects are just objects in CLOS. So, they make instance calls allocate instance to allocate one, and then it calls initialize instance to initialize it, which in turn calls shared initialize, and that's what handles the init args.
Mm-hmm. All right. So there's the question I have is that at the end of the day, there's still some consing that's going around during the object initialization phase. There's no optimization, but that could be an implementation detail that
What do you mean by optimizing that?
What does so the way malloc does is I can only talk about how C does this when you do a structure initialization. So but when you do say new, okay, in C++ or even malloc, what it does is internally it talks to the operating system to get a certain number of bytes that's contiguous, and then it will use pointer offsets to actually go initialize the object. But in Lisp, we don't have that capability with consing, right? With consing, you're getting a con cell. You're just getting a single.
No. Consing is possibly a misnomer.
Okay.
It's called consing because traditionally con cells were the only kind of object that you dealt with, but we've gotten a long ways past that by now. Consing just means allocation.
Okay.
Heap allocation specifically.
Yeah, heap allocation.
Standard heap allocation. Okay.
Yep. Consing just means heap allocation.
All right, but it doesn't return it depends on what function you're actually doing the allocation with to determine whether or not you get an actual con structure, a dotted pair, or you're going to get something else.
Right.
Okay. All right. That makes more sense now. Because I was like, how the heck did they implement this using consing? This just doesn't... I wasn't sure.
No.
Okay. All right. That makes a lot more sense now.
I mean, so this is another thing that's, some intrinsic of the runtime that we don't have access to in Portable Common Lisp, right? You can't, in Portable Common Lisp, just allocate a bunch of bytes and then declare that they're a certain object.
Right.
But there are intrinsics in the implementation that can do that.
Right. Now we have to. That's an implementation specific detail that you need to take care of.
Because it's closely related to, how the runtime of that implementation implements storage for objects.
Right.
And there's a lot of different ways you can go about that.
And that makes sense. So that's the reason why the only portability layer that you can have is the interface and nothing else, really, right? So you gotta just say that's an implementation detail for folks to deal with. But,
I mean, it is in principle feasible to allocate a bunch of bytes in on the C heap, and then manually insert a header that SBCL will recognize as an array.
Right.
That is doable. In fact, I know of one library that does that for a lot of implementations. It's useful for passing stuff to C.
So you're allocating into a C heap, but you're labeling it in a way that it's accessible through the rest of the Lisp runtime.
Yep.
Okay. Yeah, I think...
And that only works if you're dealing with a Lisp that has a specialized array representation that actually represents the raw data the same way C does. But a lot of implementations, for example, will give you that for, floats.
Interesting.
Michael, do you know what library I'm talking about? I'm sure you've used it.
Static vectors.
Static vectors, yep.
Interesting.
I use it all the time.
Yeah,
it's very useful for efficient code working.
Yeah, and literally
passing back and forth from C to Lisp.
Literally, what it does is it allocates some raw data on the C side, and then it manually tags it with the right thing to make SBCL think that data represents an array of floats, usually. And because SBCL treats arrays of floats as just raw packed data, the representation at runtime is the same on the C side or the Lisp side, so the object works for both.
Interesting.
Yep.
Okay. So this
sort of assumes that the implementation supports IEEE floats, though.
Right, exactly.
And if it doesn't, you'd have to use the library IEEE floats, IEEE floats.
Yeah.
What implementation nowadays is not IEEE compliant?
Probably
Genera.
None. Oh, really?
Genera.
Well, Genera is legally questionable anyway.
Fair.
I'm sure that Genera is on live support, and even on live support, someone went and said, maybe this thing needs to get IEEE support, so they wrote a library for it. Because, I mean,
that's what the IEEE floats library does. It's an implementation of IEEE floats in portable CL. It's a slow one, but it exists.
Interesting. So the Metaobject protocol really is just the interface. It is for to define objects in a standard Lisp implementation, but it's done in a portable way.
Reasonably portable.
Reasonably portable. It's a specification that implementers can decide whether or not they could port it.
Yeah.
So,
the Metaobject protocol is a specification for an interface to CLOS that presents the internal machinery of CLOS in terms of CLOS.
Okay, repeat that again.
The Metaobject protocol is a specification for an interface to the internals of CLOS that presents those internals in terms of CLOS.
Okay, right. So it's self-hosting. It implements it as an object in terms of itself, so that you can. But it's still lower level. It's still a specification. It's not an actual.
Really, my point is that CLOS itself doesn't need to be circular, per se. Internally, CLOS doesn't need to be circular, and in fact, it can't be. It has to self-host at some point. It has to bootstrap at some point, I mean. But internally, it doesn't even need to be. All that there needs to be is special cases in the interface for when you're dealing with a real meta object of the underlying CLOS implementation versus a meta object that you've defined.
Interesting. Okay.
Because you can only interact with the Metaobject protocol using the interface of the Metaobject protocol. And so it can basically, and saying this is misleading, it can lie to you about things. about details of like the actual objects of your underlying Lisp image, right? But it lies to you specifically in ways that make CLOS look more consistent.
Got it. Okay, and that makes sense because you're getting a bunch of stuff in the API for free, and while it is hidden, you don't necessarily know what your Lisp implementation is actually doing, and you shouldn't care actually in a lot of cases.
Correct. So when you know the Metaobject protocol, if you ask it, will tell you that yes, standard object is an instance of standard class. But was standard object created by calling make instance on standard class? No, it couldn't have been. There wasn't nearly enough machinery around it whenever standard class was created for that to work at all. Right? That's my point. Is that the MOP will tell you that standard class is an instance of standard object, and in a lot of ways, standard class will behave like an instance of standard object as far as the MOP is concerned. But it wasn't created using the protocol for creating a meta object. It was created using some other means, and it just looks like an instance of standard object.
Right. Okay. That makes sense.
Through the lens of the MOP.
Yeah, it's kind of, you know,
we're speaking very
and mind bending over here, because to understand the MOP, you have to understand CLOS. But to understand CLOS, you have to understand the MOP. So there's a lot of bootstrapping.
So the MOP redefines how a lot of the CLOS internals work, or rather, it exposes how a lot of the CLOS internals work. But it doesn't really expose them, because it exposes something that acts like CLOS and integrates with CLOS, but uses CLOS's own machinery to do its work. And so it it's really circular. So it lets you extend the behavior of CLOS, but it doesn't actually expose the internals of standard object.
Okay, that's a very meta statement. So
it lets you create things that behave like standard object, but it doesn't actually expose the true internals of standard object to you.
Okay, yeah, that's right, and that makes sense. The only thing that's available to you for standard object is whatever the API for standard object is
right.
Exposed to you, and that rightfully so, right? You don't want people to actually know how the thing is implemented. You want them to actually program to the interface, right?
Correct.
So, let me ask one question on this, because you alluded to this earlier when we were talking about initialized instance and finalized inheritance, and that is, it's interesting that they do this, but it kind of makes sense when you start looking at how inheritance actually works. But they explicitly stated that in order to implement class precedence and I think it is only class precedence, they leveraged a topological sort and remove duplicates. Now, removing duplicates, like if you have classes that are subclasses of other things, like would that actually at all change the behavior? Like for like
it shouldn't.
Okay.
Really what it's just is, so it does a topological sort, right? But the thing is that the final class precedence list of a given class won't have duplicates in it, right? That if I subclass from A and B, and A and B both subclass from C, I'm not going to have C show up twice in my precedence list.
Okay, so it's making a DAG for the precedence list, but it doesn't necessarily change the behavior of like the generic functions, like when you're actually looking it up.
The ordering doesn't change.
Okay, got it. All right.
All that's happening is that, like, so if it just did a topological sort, right, what you would see is, my precedence list would look something like A, B, C, C. Right? But that's not what precedence list looks like, because a precedence list is defined as to not have duplicates in it.
Got it. Okay. All right. That's a good point to keep note, because
that's
when I was
not
going
how it works in C++.
Yes.
Not how it works in C++. It's important to remember.
Does that even have forward definitions? I forgot.
C++? Don't think so, but I'm not sure.
Forward references? Yeah, you can.
Well, yeah, you can forward reference a class, yeah.
Yeah. You can forward reference a class, and that's resolved when at compile time. But it doesn't deal with the diamond inheritance problem
And
at
not
all.
many systems do. CLOS is special in that way.
Which is what we're talking about here. I was like, this thing actually deals with the diamond inheritance by just creating a DAG. That's a interesting thing to know. But doesn't that change the behavior? That's the question that comes in my head.
Well, it depends what you mean by change the behavior.
Just when you're calling a function that's a subclass of like you have two sibling classes, okay, and you have they both implement a method or override that is coming from the superclass that they both inherit from. All right. How would, when you're computing slot precedence, okay, how would that ordering work, like from most specific to least specific, following what
left to right?
It will still be left to right. Okay.
All right. The short answer. So if I subclass A and B, and A and B both subclass C, there will be some order in my direct superclasses list, and that's used to resolve ties.
Okay. Yeah, and that's what they meant by the standard tiebreaker rule. Okay, got it. All right, that makes sense.
Yep, I'm either going to list A first or B first, and whichever one comes first is the more important one.
Gotcha.
And that can be actually really important to remember sometimes. It's a bit of an arbitrary rule, but it's used consistently everywhere, and so it's easy to remember and easy to work around, relatively easy to work around. There aren't a lot of cases where you need to work around it, but occasionally you do, and so it's good to remember.
Right, and that's why I bring it up, because it is a very important, I would feel, when you're dealing with standard method overrides, to understand how the ordering works, especially when you start adding things like standard method combination into
there is actually something, this particular choice of setting it up actually made it impossible to construct certain class hierarchies.
Really?
Yes.
Could we write through an example that breaks this down? Okay.
Def class A, def class B.
Okay, def class A. I'm not going to put any slots for now.
You need to give an empty slots list.
Oh, right. Sorry. Yeah. That's right.
You can do it all in one line.
Oh, yeah.
You know?
Yeah, I'll do that. Okay. Class B. Okay, they're both.
Def class C inherits from A and B.
Okay.
Def class D inherits from B and A.
Class D inherits from B and A.
Mm-hmm.
Okay.
Def class E inherits from C and D.
Oops.
Now load all those in.
Okay. Ooh. Error while computing the class precedence. It is not possible to compute the class precedence list because of the circularity. Ah, nice. Okay. So let me go back to that. I thought it would open up in a different window, but it did not. I see. Okay. So if we're looking at this, hold on. I'm going to make sure I have this kind of documented. So it's A goes to B, which now then, sorry, A and B are at the top level. And then you have inheritance here going to C. But there's still, see,
Yeah, the issue is you can topologically sort this, but you can't define any ordering.
Right. Okay, I see what this is. The ordering of this, since A and B and A orderings changed, although the topologically sorted graph will still remove this precedence to give you kind of a listing. There's no real way for at least E to actually get the right precedence.
There's no consistent way to define the precedence for E.
Yeah, there's no consistent way.
Because C is requiring that A have higher precedence than B, but D is requiring that B have higher precedence than A.
Right, but in this case, couldn't you change? You can override the
You'd need to
tiebreaker
change
rule.
the definition of either C or D.
You need to change the definition of C or D.
Actually, you might be able to solve it by explicitly giving A and B in E's precedence list higher up than C and D.
But what about couldn't you change the tiebreaker ruling? Like if you
No.
see this kind of situation?
Nope.
Nope. Okay.
So can you try something for me? Because
Yeah,
I've
sure.
never actually screwed with this. Add A and B to the front of E's precedence list.
Oh, okay. Like that?
Yep.
Okay.
Nope, still
Okay.
won't let you do that. Okay.
No. That's interesting. I mean, it makes kind of some sense because of the fact that C and D is what's screwing up this situation. But yeah, okay. This is actually this is an example. I'm just going to go ahead and write this. For folks who are watching, I will post this on AFP's GitHub repo with some examples on stuff that we can't do. And then as we go through, I'm going to try and come up with a more complete example of a dumb class that implements some stuff with the Metaobject protocol so that we can, go through it in a little bit more detail. So today's kind of like more of a clarification of definitions that are presented in the book. We'll come up with a better case study as time goes on. What cannot be modeled in CLOS?
We could write an ORM.
That's a great idea, I guess. That's the standard thing to do, right?
Yeah, it's the canonical excuse for using the MOP for nonsense.
Nonsense is another statement.
Yeah.
There are a lot of other examples of stuff of doing it, but the ORM is the canonical case study of implementing stuff with the MOP. And I've seen at least 3 ORMs that did it. Elephant is probably the one that I'm most familiar with, though.
Postmodern?
I've never used postmodern. I mean, I know it exists, but I didn't think that they used a MOP for creating persistence classes. I thought postmodern just had some conveniences to hook into Postgres.
I mean, if they're defining classes that way, unless they do some... I actually have not checked, to be honest. I just sort of assumed that because, they're doing some class nonsense, that they're probably using the MOP for it.
Well, I'm looking at it right now because you brought it up. And from what I could tell, let's see. Oh,
They rely on closer MOP. Oh, they have a feature flag for it. Postmodern use MOP. Huh.
Yeah. If they do that and you want an ORM, they have a meta class called DAO class.
Oh, yeah, that's right. I remember that now.
To actually do it, but it's only if you end up enabling it. It's not enabled by default, which is why I never noticed it. Kind of nice though. I'm usually, I won't lie, I have kind of an allergy towards a lot of ORMs just because
you're not alone.
You're not alone.
For various reasons. The most important of which is there are queries that can never be properly modeled by a good ORM. ORMs don't know how to write queries very well. And that kind of really messes with performance of an application.
So ORMs kind of go against relational theory altogether. I mean,
right. But like I said, I have folks who tried to convince me otherwise, and I'm just like, look, whatever floats your boat, man. If you think you can get it fast enough, just go for it. But I've just never.
Although the worst instance of MOP that I've ever seen, and I think I think I know which one it is.
I think I know which one it is.
CLJSON.
Yep. Oh god, that
basically you can create an instance of any JSON object, and all the slots of that instance of that class have all the slots of any other JSON object. They're called fluid classes, and they're treated as unbound slots when they don't actually exist for all intents and purposes. And it's just stupid. So you have all these slots in every single JSON object, and you don't know which ones are actually usable.
Didn't you say CLJSON is also the one that's very slow, or is that a different library?
It is very slow, yes.
Okay. That's that. I was trying to recall because when we talked about it in the past, I remember in that table, that website you sent out, one of them being like the slowest of them all. Like, don't even
Yeah.
bother trying to.
That could have been it. It makes, yeah, I think that rings a bell. Yeah.
Yeah.
Wouldn't be
JS
surprised.
own would be like the fastest, I believe. But
Sorry,
it's a really, really bad parser.
stupid Jitsi decided to when I tried to hide it.
Anyway,
I've used Jonathan to pretty good success before, but apparently it can cause image corruption. So
oh, that's fun.
yeah, I've never experienced image corruption with it, but I know
How do
people
you,
that have.
how, that sounds either like an implementation bug or they're using some kind of C machinery.
They're doing weird nonsense with speed.
Oh.
Yeah.
Yeah, I've actually encountered some similar issues.
Anyway,
not even changing safety. You can corrupt your image by
but yeah.
I'm going to give this fair warning for folks who are reading, who are following along in the book, that section 1.9 is very, very important to read. I know you might think, oh, closed set seems pretty simple. Let's implement it this way, and it very, very explicitly says that closed set is woefully inefficient. Any real implementation of CLOS must handle function invocation and slot access more efficiently than the way they presented in here. So as you go through the closed set implementation that's in the back of the book, try to find ways on how to improve the performance using the features of your Lisp implementation, if not what's already available in the standard, just because you might end up becoming really disappointed if you try to pretend that this is a real implementation of Common Lisp in the object system, and if you used it in like a side project to demonstrate how it works, it's going to really, really disappoint you. So, but I'm going to bring that up. I'm just mentioning that right now before we move on. Let me see, what is the last thing I want to discuss here, which is in my list of notes. Here it is. It is page. Here we go. The method implementation for def method and generic functions. When I was looking at the generic function implementation that they have in section 1.6, which is page 34 in the book, it looked almost as if that standard method and standard generic function are not related to each other at all.
They're not.
So, because I'm seeing duplication here, like lambda list for the method, which looks up the methods that have implementations, and then standard method has a pointer to the generic function. So is that kind of the meta circularity here then also at play? Like they're like...
I'd need to dig into it a bit more than I have.
Okay.
But standard method and standard generic function, I mean, they're related in the API sense, but they're very different objects. A standard method represents a single method that you define using def method, whereas the standard generic function represents the actual collection of methods.
Right. So standard method is not actually a subclass for standard generic function. Rather, a standard generic function holds a collection of the method implementation.
Correct.
Yeah. Okay, got it. So it's object composition rather than inheritance in this case. Okay.
Yeah, very much.
Okay.
I don't think you can even do that using an inheritance model.
I don't think you can, but then again.
But yeah.
There's the other interesting note is the qualifiers versus specializers. Now, I'm not sure if I so it's the qualifiers when you're specifying the arguments and they're like if you're doing, let's say, let me get come up with an example here. Let's say that you decided to do.
So
you
so
know,
the qualifiers are just the things in the in your def method that come before the arg list but after the name. So it's like the around, the after, the plus, the prog-n, the
okay, so that's different. That's
those are the
not
qualifiers.
okay.
Um,
The qualifiers is how you're actually combining the form of combination, and if there's nothing,
Right.
that could be empty.
Whereas the specializers are which classes are set for each arg, and like your EQL specializers and such.
Okay, and as well as the argument names if they're restricted on a particular object, so that you can do a quick lookup, right? Okay. The one thing that I found interesting to this, and this is kind of related to something that we brought up in past episodes, and that is the notion of environment. Because I thought that there wasn't an environment API, but it seems to be that there is some sort of an environment API that's just not exposed.
Well, every implementation has to have some representation of the global environment.
Right, but it's just not a standardized API that.
Correct.
Okay.
Right. There's portability libraries for that, though.
Okay. Cool.
To some extent.
Which is the one that you guys mentioned? There was one that you guys mentioned.
Introspect environment.
CL environments.
That's the one.
Or that.
Okay. CL environments is the one. Okay.
But both of them are useful really for getting access to information in the compilation environment when you're doing stuff with macros, but you can use them a bit more generally than that.
Cool. All right. Yeah.
There isn't a whole lot of information in the compilation environment, but there's some there. It can be useful sometimes.
Nice. Okay.
Mostly useful for compiler macros.
Yeah.
So the qualifier from a couple of weeks ago was actually the filter keyword for the filtered functions.
Right.
Also.
Right.
There's another example of a qualifier. Custom qualifier, nonetheless.
Actually, I still think I have that code somewhere sitting in my
So the thing to really remember is that basically every method is a list of qualifiers, right?
Right.
And a list of specializers. And the list of specializers is the same length as the number of positional arguments, positional required arguments.
Right.
It's always the same length as the number of required positional arguments because it matches 1-to-1 for each of the required positional arguments.
If that's the case, then wouldn't how does how would this handle rest arguments then? Since those
You can't.
Okay, got it.
You can use rest arguments, but you can't dispatch on them.
Oh, right. That makes sense. So specializers is mainly specific for method dispatch.
Specializers are how you do method dispatch.
Got it. Okay.
The specializer tells you whether or not a given method is applicable to a given set of arguments.
Okay.
And the qualifier then tells you how to combine that with the other applicable methods.
Got it. Okay, that makes sense. Because you needed some sort of finite list to actually do the dispatch. I was wondering.
Yeah, you can't dispatch on any optional arguments. Key, optional, or rest.
Yep, you can only dispatch on the required positional ones.
Okay.
And basically every method is identified to its generic function by its list of qualifiers and specializers. Right? And so that's how you can do method redefinition, is that there's some table in the generic function which maps from your set of qualifiers and your set of specializers to the method object.
Right.
So
I think that's how I would think that generic function methods, as part of the standard generic function class, the accessor is just doing a lookup on a hash table of some sort.
Something like that.
Yeah. Just to keep to do the quick.
I mean, it's a bit more complicated than that because you do have to do the method combination. And extra stuff along those lines. One of these days, we should get to the point, I hope we get to the point where we've exposed enough that we can actually, dig into Robert Strand's proposals for how Sickles' object system should be implemented, because that'll really, explain a lot of these details in a much more concrete way.
I think we're closing in on that, and I'm hopeful that in the coming weeks, as we finish this off, it will enable us to do that, and then we could start doing some code review with some of the design proposals. If anything, this is more ambitious. Implement some of them to see if we could see how far we can go with doing some of it inside SDCL. But it requires a little bit more of an understanding, I think, of the MOP itself and how to extend Lisp to get into some of his proposals. Because not even mentioning SYCL, I think Robert Strand's operating system thing requires something that to do some sort of layering requires the MOP. At least if I remember and how I understood it at the time. But then back then I didn't understand them. I didn't dig into the MOP, so I'm not familiar with that. So yeah.
But yeah.
Okay. Yeah, that's all the questions I have, folks.
Okay.
Who are online and who are watching us right now, if there are any questions, we'll kind of wait for a few minutes to see if there are any running questions, and if not, we will close out. And next week we'll start talking about object introspection in the MOP. Hopefully, come up with a set of design goals on how to design your own MOP if you need to, because I think Chapter 2, it's either Chapter 2 or Chapter 3 that deals with some of those guidelines for MOP design. While we're waiting for the YouTubers to post questions, I have a question for you, Michael. When is did you say that the game jam is in April usually?
Yeah, it's biannually. We usually do it mid-April and mid-October. So yeah, probably I think we do the second week of mid-April. So I think we started on a Friday. So whatever the second Friday of the month is, that'll probably be when it starts.
All right. As things get closer, I will start really plugging it. But I just wanted to at least ask because I was looking at what was it? I think Blackthorn the other day, and see if I could revive it.
Oh God. Ancient. Wow, I haven't heard that name in ages.
Yes, I know. Hold on. Yes, Chapter 1 is completed, Richie. There are, if you have any questions, feel free to post them right now, and then we can. These are the questions I had, at least for Chapter 1. Yeah, so any questions from you, we'll gladly take them and discuss them.
But yeah, regarding the game jam, I planned on to at least do a stream, maybe two, to cover some, useful libraries and engines and whatnot that can be used for the game jam, since we haven't really done anything like that yet on stream.
That'd be nice.
Me and Ram were talking about it before the stream began. Yeah, that would be a good idea, I think.
Yeah, that'll be a great idea. I think it'll be a nice little preparation, and hopefully will entice folks to check it out. All right, that's it for me. Thanks for all those that have joined us. Next week, like I said, we're going to be covering Chapter 2, which is on object introspection. It's going to be a real hoot. Again, topics. If you guys have a topic that you'd like us to discuss, feel free to post it on the CL study group on Mattermost at chat.lisp.cl. Also, I'm available on functionalprogramming.slack as well as the Lisp Discord server. So different avenues, but I'll get the information. We'll put it on the list of things to talk about. Till then, I'll talk to you guys later. Thanks for joining me, Michael and Elijah.
Yep, thank you.
All right.
Bye.
Bye then.